Howdy, my name is Sahat Jaldu, and this is my deep demo video for the 2025-2026 academic year. This project is titled Fourier Music. What I have right now is I've hooked up an Akai MPK Mini up to my laptop, just the keyboard, and that's being put into this software called Pure Data. The main goal of my project was to synthesize a cello, which I have done. I can play a little bit for you. Yeah, fun stuff. Um, the goal of this project was for me to not only synthesize a cello, but for it to be done in an educational kind of way, so that you should be able to visually see the waveform and how, as I apply different effects to it, how the waveform changes. Um, you can't see much right now, so let's open it up and take a closer look. Cool. Now here's the same cello, but revealing the inner workings. Notice as I'm going to play a little bit, so notice how the waveform changes here and here. Um, actually, do it here too. Yeah, okay. You might have noticed it shrinking and stretching as the frequency changes, or the pitch changes, I guess. That's the same thing. Another, yeah, this whole thing looks a little bit complicated right now, but let me take you through it step by step. Cool. Start here. A note in block that comes from the keyboard goes to a MIDI number. Every single key outputs a different number, which is taken through a MIDI to frequency converter, and as a result, this is the corresponding frequency, 130.8 hertz. Then I multiply that frequency by 1, 2, 3, 4, 5, etc., integer values, and add them all together. Without doing that, this kind of sounds like this, but now let's add each of the overtones, what these are called, the integer multiples. So I get a much more tonally rich sound. I'll explain more about that later. Then I apply the vibrato to it. This is just a low frequency oscillator um, added to each of these numbers so that it increases and decreases over time. This is what it looks like after vibrato. This is what it looks like before. There's a little bit of a difference. It's a little minute. Then I apply some volume changes. Then it is sent over here. This bit right here is a little bit of noise that I add right at the beginning of each note. This is supposed to emulate the crunch of the bow on the cello. Um, Here, perhaps you can hear it. Oh, oops. It's a little bit subtle. You might have heard it right at the beginning of each note. Then, afterwards, it is taken through these three bandpass filters. These, the shape of the cello filters out a few frequencies, a few frequency ranges on its own. Um, Stuff around 180 hertz, 500 hertz, and 2500 hertz. This is meant to emulate that. A previous version that I had used had frequencies that were just a little bit higher, about 100 hertz higher for this one, etc. And it ended up sounding like an oboe, which is very interesting. So this bit, just changing this can, you know, it counts a lot, I guess. Then I have this is applied, a volume envelope is applied to it. In more technical terms, this is an ADSR envelope. This is supposed to emulate how the volume changes as I use a bow on the strings, or how it would when I use a bow on the strings. The ADSR stands for attack, decay, sustain, and release. Where, here, okay, watch this bit right now while I play it now. This is the volume. The attack is the first part, how it goes up, the time in which it goes up to 100% volume. then it decays to 75% volume. It sustains at 75% volume for some more time, then it decays back down to zero. So because I wanted to emulate a quick attack of the bow, I used a very fast attack, about 100 milliseconds. Um, and just about 100 milliseconds for the decay, sorry, AD, yeah, decay, and then 100 milliseconds for the sustain, and then about 200 milliseconds for the release. Then after that, um, oh yeah, I apply the same line to another filter just to emulate how the bow might change the tone as it moves down the strings. It's supposed to add a little bit of variableness to it and make it sound a little less clean and more natural. The volume is adjusted and then it goes to output. And that results in this final waveform. Very cool stuff. Now, there are two main parts that I want to talk about here. First one is, hang on. The first part is what I mentioned before, these bits right here. What I'm adding, these integer multiples, are called overtones. And every single natural sound has its own set of overtones. A bell will have its own set of overtones. A horn will have its own set of overtones. Hitting your hand against the wall will have its own overtones. Even your voice has its own overtones. We can take a closer look at that specifically, actually. What I have done here is I have hooked up my microphone to a Fourier transform. It's very cool. The Fourier transform, it takes the complex waveform that is my voice and splits it up into the individual waveforms that make it up. Um, and then it plots them, or what I've done, I've plotted them on this graph right here. So what you're seeing is the frequency domain, and each one of these spikes is a different frequency. Or specifically, these spikes are my overtones. If I sustain a single note, you will be able to hear it a lot easier, or see it a lot easily. Uh, so those were my overtones. Yeah, very cool stuff. Whereas when I put in a singular note, this is just one sine wave at 440 hertz, it ends up as just one spike in the frequency domain. And as I change the frequency, it moves up and down. So what's meant in order to emulate instruments, what a lot of people will do is they'll play that instrument, put that into a microphone, and do various transforms like the Fourier transform to analyze the overtones of the instrument and various other properties. And then you recreate it in some sort of software here. Another thing that made up a large part of this project is the specific waveform I used to build it up. These phasors make sawtooth waves, which kind of look like this. They look like a sawtooth. Um, a previous version that I had used sine waves instead. That sounded a little bit different. All right, here is version one. Actually, let's. Notice how it's a lot more round and more nasal. It sounds a little bit like a frog. So just changing the individual waves that make this up can change how the sound sounds a lot. There are what's regarded as four fundamental waveforms: um, sine wave, sawtooth wave, square wave, triangle wave, and I'll go through each of them. You already heard the sine wave in version one of my cello. Then the sawtooth wave is what I used in the final version. Then the square wave. A lot of old game systems would use square waves just because they're the easiest to make with a circuit. All you have to do is increase and decrease a voltage by a constant amount. Then a triangle wave. Interestingly, the triangle wave sounds a lot like the sine wave, just because it kind of looks similar. But yeah, those are just by adding different, types of waves, by doing all these different effects, you can get a lot of different sounds, whether that emulates real instruments or goes beyond that. Thank you.